Do you guys see my view?
Yes.
Okay. Yeah.
So if I forward and you see it, right?
Yeah.
Okay. All right. So this is a slide deck from one of the training at the conferences, and I figure it's pretty useful. And this guy did a good job, so I figure I use it instead of using my own. We might skip a lot of these that are not relevant to us in terms of who this guy is, about Databricks and stuff like that. And feel free to jump in and ask questions along the way. We can stop and dive deeper in any of these. I sent you guys, and looks like Jennifer said this is at the right level, so I'm glad to hear that. I was kind of afraid whether this is too basics or not. Okay, so they're talking about, this is the RDD. RDD behind the scene is represented by data that you have, right? When you reading from HDFS, a local machine, and an RDD consists of partitions, meaning that this is a little bit technical. I'm not sure you guys need to know, but on HDFS, when you store a file, it's broken down to blocks. And then in RDD, each partition is mapped to one of those blocks on Hadoop. And each RDD has a function. You're probably familiar with the function in terms of do transformation or filtering or whatnot.
Mm-hmm.
And then the driver is your main application, the guy that starts the application. When you run your Spark shell, it already starts the driver for you. But if you were going to write an application and submit to the either Yarn or Spark cluster, you have to have your own application that's packaged in a Scala or Python code, and then you compile that down and then package in a jar, and then you submit that jar to the cluster. And that has your application as well as the driver in there. The driver does a lot of stuff, but it depends on how deep you want to go in there. So, all right, Spark operations. So we're going to be mainly focused on this because you're going to be using a lot of these stuff. Are you guys familiar with there's two types of operations in Spark?
Not in a theoretical way.
Okay, so let me kind of spend 2 seconds on that. So there's two kinds of things in Spark operations. There's two types. One of them is being called transformations, and the other one is actions. So what's the difference, right? The first very big difference is transformation, like filter, map, and stuff like that, are lazy evaluated. Okay, so when you say filter or map, Spark's not going to go and execute that directly. It will wait until the moment you enter one of these actions. So what's an action? An action is like count, collect, things like that. So you might have a bunch of logic doing all kinds of transformation, filter, map, join, and whatnot. And then the moment you say count or you say save as, that's when Spark takes all that logic and then compiles down to tasks and execute them and stuff like that. So the one big difference, the takeaway is transformation are lazy evaluated. Okay?
Got it.
And when you enter an action, that's when Spark's going to create jobs, and then each job has different phases, and each phase has multiple tasks. So that's kind of how I work. All right, so as you can see, there's a different sets of transformation and action that you on that slide, right? You got filter, flat map, map partition, doing set theories, union, intersection, and all that stuff. So we're probably not going to go through every single one of these. We'll pick and choose, and then feel free to ask any questions for the one that I'm not going to cover. Okay, so in the RDD world, you can work with unstructured data, meaning that you're reading a text line by line, and you split by space and whatnot. There's also another concept called pair RDD, which has key and value. A key doesn't mean it has a single value only. It could have multiple values in there, so they call that composite key. As the same thing with value. It could be a single value like string, or it could be an object that contains multiple fields in there. But why do we have pair RDD? Because a lot of these operations, like reduce by key, right, combine by key and group by key or whatnot, only works on the pair RDD which has key and value. Okay, because any kind of grouping that you do, usually you have a key and a values, and all these operation or transformations work with pair RDDs.
And that will be faster than if you have a regular RDD and
well, it's
no,
not.
I guess yeah. It's
not,
just that you have to have it in that format in order to reduce by key.
Yeah, because like for example, if you want to group all the people that work in California, for example, right? So you got to have a key. A key would be a state, for example. Without a key and value, there isn't really a way to do any kind of grouping.
But does Spark then sort of like implicit or Scala implicitly assign that structure? Because I've been able to reduce by key without having sort of explicitly.
Because Spark makes it very easy. You probably did it without realizing it, because the moment you put in a tuple, right, parenthesis, the first value, second value, the first value is the key, even though you didn't realize that. Yeah. So like if you, well, okay, well,
no,
anything
I get
else?
It. Yep.
Yeah. Okay. All right. So with pair, once you have a pair RDD, then these additional transformation and action are available to you. Otherwise.
Oh, sorry, I do have a question.
Yeah.
So in action, so what's the difference between the reduce by key transformation and the count by value action?
Okay, so the reduce by key allows you to operate on the values for each of the keys, and you specify a function like addition or whatnot. Again, transformation is lazy evaluated, right? When you do reduce by key, nothing happens. And then finally, you do count by key. The difference is the second one is an action, basically. Because with transformation reduced by key, after you do that, you can do additional kind of transformation on the result of that RDD.
Yeah, so actually, so if I wanted to, if I just wanted to get like a table of like, you know, how many records I have for each of the 50 states.
Yeah.
I could either reduce by key and then count by value, but I could also count by value just from on the initial.
Yes. Pair RDDs. Yeah.
RDD.
Yeah.
But that is there like a problem with doing that?
No. The flexibility with doing reduce by key, let's say you do that, and then now you do additional filtering. You only want states that have a count of greater than 30, right? So you do reduce by key, and then you do additional filtering after that.
Yeah, got it.
Yeah. So that's a slight difference, but yeah. Okay. Good question, though. All right. So they talk about the narrow dependency versus wide dependency. Narrow means that the dependency of RDD to its parent is 1-to-1, right? So each partition, like for example, you do flat map, or you do a map or filter. So all the data in that partition, each of these blocks means partition, by the way. So if you do like a filter, then what Spark does is sends that filtering logic down to each of the tasks, and each task operates on that one partition. So that's narrow partition. Wide partitions, anytime you do any kind of grouping, sorting, reduce by key, then it has to like bring all the values with the same key together onto a single partition, right? So therefore, one of the partition on the right-hand side, the values will have to come from multiple places, and that's what they call wide dependency. That's more like internal stuff, but just as you can imagine,
it's helpful to understand that that's in the background.
Yeah.
So and what's the color? What's the color mean?
The color mean is the blue is the parent, and the orange is mean like the child.
Got it.
The one takeaway is with Y dependencies means that data has to be shuffled around. So therefore, it's a lot more expensive than the narrow dependency. Okay? That's the main takeaway. All right, lineage is pretty simple. It's, every time you create an RDD, anytime you do like filtering or transformation or things like that, RDD are meant to be immutable, right? You can't change the RDD. If you do a transformation, it creates another RDD, and it maintains the lineage information inside the RDD. So that's all it is. All right, it talks more about, so it gives more example when a narrow dependency happens, when a wide dependency happens, and it maps that to the kinds of transformation. For example, you do map filter, that's narrow dependency, as well as union. But the moment you do group by key or you do join, that's when it creates a wide dependency. Okay. All right. I'm sure you need to know what map does, but I'm going to be very quickly go through each one of these. So map, you can look at the code. So it's pretty simple here. It creates an array, parallelize it, and so map. So Jennifer, do you see like on the line it say val y equal x dot map z and then parentheses z comma 1?
Yeah. By the way, it's Jessica.
Oh, sorry, Jessica.
No worries. I get Jennifer all the time.
When you see parentheses z comma 1, that's when it creates a tuple.
Yeah.
And that's when you create key value pair RDDs.
Yeah.
Okay. Yeah. So map basically iterate through each of the items in a collection or record, and then create another object from that. So a transformation could be. Go ahead.
Sorry, I was just going to ask about the parallelize.
Oh yeah.
Is that just essentially? So here, B, A, and C are, they're just the letters, right? And you're just essentially placing each of these letters on a different partition?
Yes, in this example, because the method parallelize can take one additional parameter called number of partitions. Since the example didn't give that number of partition, it's going to be placed on 1. But you're right. If I say comma 3, then you see B in one partition, A in one partition, and C on a separate partition.
Is that parallelize seeming like a for loop, sort of, like for each of this item?
No, what it does is when we create an array of A, B, C, that's just local, right? The moment we say parallelized, then now this collection is going to be a distributed collection that Spark can operate on, right? So if you create an array, then you cannot use Spark's APIs because those are just collections. The moment you say parallelized, then it becomes an RDD. That's the difference.
Can you? Oh, okay, so parallelize is essentially doing the same thing as if I had specified the RDD. If I had specified that X is an RDD with an array as its member, then
no. So
that would have been the same as parallelize.
Let me back up. So in Spark, there are three ways to create an RDD. One is you load from disk, right? When you load Avro data from HDFS through that API, it creates an RDD. The second way is using the parallelize method that we just saw here. The third way is when you take an RDD and you perform any kind of transformation on it, like x.map, that creates a new RDD.
Those are the only 3 ways.
Yeah.
So I have a line in my file where I I'm gonna send this by chat so you can
Are we using Cisco Jabber?
sorry, no, just through the Blue Jeans.
Oh, that's the way you do that. Okay.
I just want you to
Sure. Send it over.
so I just sent it. I don't know if you can see it if you click on the little like speaking bubble.
Oh yeah. Oh yeah, I see it.
And so here the reason basically this becomes an RDD because I'm performing a transformation on existing RDDs.
Yes. Yep. If you have an existing if you have an existing RDD and you do any kind of transformation on it, it will create a new RDD.
And that's really just because of the like vertices attribute dot map. That's like that's the part of it that is, execute a transformation on this existing RDD. Therefore, the inheriting object is going to be an RDD as well. Yeah, hello?
Hello? We might.
I guess I'll just come back on.
Let me pause the recording. Don't know what's going on.